Here's the table that I used for r equals sine of 2 theta. Now remember, we want the argument of the sine function to change not by too much. If we use theta equals 0, pi over 4, pi over 2, 3 pi over 4, and so forth, multiples of pi over 4, this wouldn't have worked out as well. And if we used multiples of pi over 6, actually would have been really messed up, because we would have missed the arguments pi over 2 and 3 pi over 2. Okay? And that would have been a serious error, as you can see if you try it. Okay? Since we're doing 2 theta, we'd better let theta change by pi over 8. That way we'll get the pi over 4 multiples when we take the sine. Okay? So we're letting theta go by pi over 8s, and we get our r values for the sine of 0, sine of pi over 4, sine of pi over 2, 3 pi over 4, and so forth. Okay? We have to use the multiples of pi over 8 to do that because of the way the 2 theta works. Then when we sketch the graph, what do we get? Well, the point 0, 0, of course, is the pole. Pi over 8, 0.71. And then pi over 4, 1. Let's come out to pi over 4, 1, because that's going to be our extreme value. That's going to occur right here. Okay? And the pi over 8.71, well, that's going to be down here between 0 and pi over 4, and not quite as far out as the 1, about 3/4, 2/3 as far. And then the 3 pi over 8 is going to give us another 0.71. That's going to be somewhere like right about here. Same distance from the pole as the pi over 8. And then the pi over 2 is going to give us 0. So that you see, in going from 0 to pi over 2, we've gone through a complete half cycle of the sine function from 0 out to 1 and back to 0. And now we're going to go through the negative values of the sine function. So as we go from pi over 2 to pi, 5 pi over 8, our displacement is negative 0.71. So we come out in the direction 5 pi over 8, but a negative displacement, which puts us down here. And then 3 pi over 4, negative 1, well, direction 3 pi over 4, negative 1 displacement, that gives us this point. And 7 pi over 8, negative 0.71, 7 pi over 8 is this direction, but a negative displacement is going to put us here. So we end up with another one of these things. Now, this is drawn a little bit smaller than this, just because I wasn't as careful as I might have been in drawing it. But it should be identical in size, and just kind of a reflection through the x-axis of this one up here. Okay? Now, I haven't gone through the rest of the cycle. I want you to do that. Okay, I've stopped at pi. If we go to the next multiple of pi over 8, here we've got 7 pi over 8. This is 8 pi over 8, so next will be 9 pi over 8, 10 pi over 8, 11 pi over 8, and so forth. You're going to get more graph here, and you're going to see what happens. Do you repeat like we did with the cosine and just repeat these 2 cycles? Or does something else happen? And in doing that, you'll understand a little bit about how the doubling of the angle affects the graph. And then you might want to think about what would happen if we had the sine of 3 theta or 4 theta or 5 theta up here. What would that do to the shape of the graph?